Hello and welcome. In this video we are discussing about prompt engineering. So pre-training and transfer learning. So pre-training and transfer learning are foundational concepts in prompt engineering which involve leveraging existing language models knowledge to fine-tune them for specific tasks. So in this chapter we will delve into the details of pre-training language models, the benefits of transfer learning, and how prompt engineers can utilize these techniques to optimize model performance. So pre-training language models, transformer architecture. So pre-training of language models is typically accomplished using transformer-based architectures like GPT, Generative Pre-trained Transformer, or BERT, bidirectional encoder representations from transformers. And these models utilize self-attention mechanisms to effectively capture contextual dependencies in natural language. Pre-training objectives. So during pre-training, language models are exposed to vast amounts of unstructured text data to learn language patterns and relationships. So two common pre-training objectives are masked language model MLM. So in the MLM objective, a certain percentage of tokens in the input text are randomly masked, and the model is tasked with predicting the masked tokens based on their context within the sentence. Next, sentence prediction, NSP. So the NSP objective aims to predict whether two sentences appear consecutively in a document, and this helps the model understand the discourse and coherence within longer text sequence. So benefits of transfer learning. Knowledge transfer. So pre-training language models on vast code enables them to learn general language patterns and semantics, and the knowledge gained during pre-training can then be transferred to downstream tasks, making it easier and faster to learn new tasks. Reduced data requirements. So transfer learning reduces the need for extensive task-specific training data, and by fine-tuning a pre-trained model on a smaller dataset related to the targeted task, prompt engineers can achieve competitive performance even with limited data. Faster convergence. So fine-tuning a pre-trained model requires fewer iterations and epochs compared to training a model from scratch, and this results in faster convergence and reduces computational resources needed for training. Transfer learning techniques. Feature extraction. So one transfer learning approach is feature extraction, where prompt engineers freeze the pre-trained model's weights and add task-specific layers on top, and the task-specific layers are then fine-tuned on the target dataset. Full model fine-tuning. So in full model fine-tuning, all layers of the pre-trained model are fine-tuned on the target task, and this approach allows the model to adapt its entire architecture to the specific requirements of the task. So adaptation to specific tasks. Task-specific data augmentation. So to improve the model's generalization on specific tasks, prompt engineers can use task-specific data augmentation techniques, and augmenting the training data with variations of the original samples increase the model's exposure to diverse input patterns. Domain-specific fine-tuning. For domain-specific tasks, domain-specific fine-tuning involves fine-tuning the model on data from the target domain, and this step ensures that the model captures the nuance and vocabulary specific to the task domain. So best practices for pre-training and transfer learning. Data pre-processing. Ensure that the data pre-processing steps used during pre-training are consistent with the downstream tasks, and this includes tokenization, data cleaning, and handling special characters. Prompt formulation. Tailor prompts to specific downstream tasks considering the context and user requirements. Well-crafted prompts improve the model's ability to provide accurate and relevant responses. So in this chapter we explored pre-training and transfer learning techniques in prompt engineering. So pre-training language models on vast corpus and transferring knowledge to downstream tasks have proven to be effective strategies for enhancing model performance and reducing data requirements. So by carefully fine-tuning pre-trained models and adapting them to specific tasks, prompt engineers can achieve state-of-the-art performance on various natural language processing tasks. And as we move forward, understanding and leveraging pre-training and transfer learning will remain fundamental for successful prompt engineering projects. So this was a brief discussion on prompt engineering, and we will be discussing more on prompt engineering in the upcoming videos. And if you are the first time here, subscribe to the channel by clicking the subscribe button to see the latest technology videos. Thank you for watching this video. Bye for now.